Hi, Gratovs. Welcome back to this session. Thank you very much for joining us once again. We are still continuing with probability, and today we're going to be focusing mainly on tree and Venn diagrams. Without any further ado, let's just get straight to it. Okay, let's just quickly start with Venn diagrams, and let's just help you to conceptualize this knowledge, right? Very, very interesting. All right. So what is a Venn diagram, right? A Venn diagram is actually a diagram that represents a sample space, right? And that sample space, we have events in it, right? So for example, so this four corner bracket here, right? Not four corner bracket, I mean this four corner shape here, it's showing you the sample space, right? So within the sample space we have events, right, represented by the two ovals or circles, right? So this is event A, and this is your event what? Your event B. So we call that kind of a diagram what? A Venn diagram. All right, so let's just quickly take a look at how you can actually get sort of like probabilities or certain outcomes, what it represents on the Venn diagram. Okay, so you have now your event A, it's actually that circle, right? And event B is actually this circle here, right? So obviously on the top corner there, you'll have your total number of sample space, right? You'll have your n of sample space there, right? It's mostly written at the top corner. Sometimes they can just put it outside a bit there, and that will be your sample space. Okay, so we also have these two circles, right, representing these two events, right? So any outcome that lies here, remember this is an event for A. Any outcome that lies here, it is an outcome that applies for A only. Very, very important. We are not saying it's for A, right? We are not saying it's for A, but we are saying it's for what? A only, because it does not include something for B. It's for A only, right? So there's a difference when we say A only and when we say A, right? Because when you say A only, you only imply the outcome is only for A, right? But when you just say A, you imply that it's for the whole thing there, the whole circle for A, which can also include the intersection of B. There can be B there. Okay, so be very, very careful with that. Okay, so that one is for A only, as we have said now. Also, let's come to this side. This space is for event B, so this will be for what? For B only, right? Then we also have some outcomes in between there. Obviously, that is the intersection. This will apply for both A and what? A and B. Okay, then we also have those outcomes that will be outside those two circles. Those one will be for neither what? For neither A or what? Or B, right? Neither A or B. That is, they lie outside A and what? A or B. All right, so that's actually the interpretation of that Venn diagram and what the outcome actually mean. All right. All right, let's now have a quick look at this, although we've covered it on the previous session, right? Just a reminder or quite a revision. We said that events can be mutually exclusive, right? And what that implies really is they cannot occur at the same time. That is, there's no intersection between the two, right? And you can see it on a Venn diagram where you have your event A here and your event B there, right? And you can actually see that there's no intersection between A and B, meaning that the probability of A and B is equals to what? Is equals to 0, because there's no intersection. So this implies the two events are what? Are mutually exclusive. All right. So if they are not mutually exclusive, obviously they will have certain elements in common, and that's how your Venn diagram will look like, right? So you have the intersection between A and B to show that they have something in common. Then we'll say this one are what? Are not what? Not mutually exclusive. Okay, not mutually exclusive, but these ones are what? Are mutually exclusive. All right, so parts of the Venn diagram can be shaded to show the union, intersection, or complement sets, right? As you can see, if you need the outcome for A or B, A union B is the same as what? As A or what? Or B. Okay, so A or B is everything that lies in A and everything that lies within what? In B. So we can just represent it by shading there to just show you what is A or B. So it's quite different when this is when they are mutually exclusive, but when they are not mutually exclusive, it's quite different, right? A or B, we just shade everything in A and everything in B, right? Without repeating, obviously. So obviously when you shade A first, you're gonna shade here everything and the intersection. Then when you say or B, we include everything of B, right? So without repeating, shading the intersection and so on, or rather without repeating that outcome in the intersection, because it's already shaded when we say A, right? Say A or B. So that's how we can actually represent the outcomes there. Okay, so A intersection B, there is nothing. Can you see that here? There is nothing. There's no intersection, right? That's why we didn't shade there, right? But A intersection B, that is the same as A and B, right? So here there's intersection. You can see by our shading here. So it's because there's what? There's intersection. All right. Okay, let's now look at how we can determine probabilities from Venn diagrams. Okay, I know this is quite challenging for some of you, but hopefully after this session you'll be able to conceptualize and understand this. Okay, so it says find the following probabilities. Number one, obviously using the Venn diagram, right? Number one, it wants you to determine the probability of A, right? What do you know about probability? We say how many favorable outcomes do we want from how many in total. That is probability, right? The ratio between your favorable outcomes and also the sample space. Okay, so probability of A is going to be equals to what? The number of outcomes in A divided by the number of what? Of sample space, total number of sample space. The number of outcomes in A, that is everything that is found within event A. This will be the same as M plus what? M plus X, right? Because if we assume M and X represent any number, so it will be M plus X over the total number of sample space, which is all the outcomes within our Venn diagram. So it's gonna be M plus X plus what? Plus P plus what? Plus Y. So that will be the probability of what? Of A. Let's now go to number 2. Okay, so for number 2, they want you to get the probability of A only. Okay, A only. What is the probability of A only? What is the number of outcomes in A only? They are not saying A, right? But they are saying A only. So there's a difference, right? When they say probability of A. So when we say probability of A, we just take everything that is found within event A. We don't care whether there is another outcome that is in A that is also in B, right? We just take everything. But now when we say A only, we only need the outcomes, or rather we must choose the outcomes that lies in event A only without lying also in another event. Okay, so we're gonna check for that. So this will be all outcomes within this space, right? It's only for A. So it's gonna be what? M, the number of sample space, the number of favorable outcome, it's M over the total number of what? Of sample space, which is M plus X plus P plus what? Plus Y. So that will be the probability of A only. Okay, I hope now you can now do number 3 and number 4. Okay, you can just pause the video and try to answer those ones. Okay, I'm sure you are done now. Okay, let's now go and calculate the probability of B. So with probability of B, it's all the outcomes that lies in our event what? In our event B. This will be what? X plus what? Plus P over the total number of sample space, which is M plus X plus P plus y. Okay, hopefully you got that correct. Okay, let's now move to number 4. So I'm just gonna put it down here. So for number 4, they want the probability of what? Of b only. B only. So it's all the outcomes that lie in only b, right? So it's only what? It's only our p over what? Over m plus x plus p plus y, because they need what? They need probability. Okay, let's quickly now go to number 5 and number 6. Okay, so for your number 5, they want the probability of A and B, right? A and B is on our what? On our intersection. Is the intersection between the two events. A and B is that point there, right? So it's going to be the number of event in A and B. It's only X over the total number of sample space, which is M plus X plus P plus Y. All right. Let's now lastly conclude with number 6. They want you to get the probability of A or B. This is also known as A union what? B. And number 5, this is also known as A intersection what? B, right? So intersection is something like this. All right. So A or B is everything that is found within our event A and everything that is found within event B, right? But we do not have to repeat if there's any outcome that is being repeated, right? Because it won't make sense. So A or B is just gonna be that part that we have just shaded there, right? Or rather we can shade it properly. Let me use probably this one to just shade properly so that you can see A or B is everything there, right? So it's gonna be what? It's gonna be M plus X plus P all divided by the total number of sample space M plus X plus P plus what? Plus Y. All right. So that's basically how you can calculate or rather determine the probabilities from what? From Venn diagram. Okay. Let's now quickly go and look at some of the interesting challenging questions, how you can determine these probabilities from actually complementary event. All right. Determining probabilities from Venn diagram for complementary event. This is where the challenge starts, really. Okay, so where they want you to find the probabilities of complementary events on a Venn diagram, right? But in this video, definitely you learn of a strategy that you can use in order to be able to solve all this kind of problem. Okay, so number 1, determine probability of A prime. So there's something on top, which is that dash. So it's standing for a prime, right? This can also be written as probability of not in what? Not in A, right? Of not in A, right? So we are saying probability of not in what? Not in A, right? There's actually a formula. If you want probability of A prime or not in A, you can say 1 minus probability of A. Okay, so you can use this formula to actually get the answer. But we won't use it in this case. I just want to show you how you can actually deduce this by actually doing it practically yourself and highlighting those points, because the formula only applies for such cases, right? But if you have such cases, sometimes such cases it might not really be useful. Okay, so you must know also the practical side of it, how you can actually do it by yourself. So A prime, if you see this thing on top, you just know it's A prime, it's not in A, right? Same as probability of not in A. So we just go and check. We take all outcomes that are not in A, right? It's actually the ones that are in B only and also that are outside, right? So they are not in A. So it's going to be what probability? It's going to be P plus Y divided by the whole sample space, which is M plus X plus P plus what? Plus Y. All right. So that would be the answer. Let's quickly go to this one. Probability of not in B, B prime, is the same as not in what? Not in B. What will it be the same as? Not in B, so we exclude everything that is in B, right? Not in B, so it's going to be everything outside the circle for B, even B. So it's going to be M plus Y, right? So it's going to be m plus y, all divided by the total number of sample space, m plus x plus p plus what? Plus y. All right. Let's go to number 3 now. I'll just put it this side. Number 3. So for number 3, very, very important and very quite challenging, right? So they want you to determine the probability of not in A or not in B, right? It's the same as probability of not A or what? Or not B. So how do you actually go and solve this? So what you do is you go and first determine for not A and also draw a Venn diagram for not B. And or, what does or mean? You take everything for not A and everything for what? For not B. So that's actually how you go about that. So what I'm going to do quickly, I'm just going to draw 2 Venn diagrams, right? I'll draw the other one this side, the other one this side. Okay, so it's A and B, A, B. It's A, B, right? A, B. So I'm just going to take not A. This one I will name it not A. And this one I will name it what? Not B. Okay. So not A, I'm just going to highlight with red. Not in A, it means we are including everything that is outside what? That is outside A, right? So that is outside that event A. So it's actually those things there. Or rather, let me just use a highlighter for that, just to show you really not A. It's everything there. It's not A, right? We are not including A. So we go to not B, right? Not in B, it will be everything that is outside the circle of B, right? There we go. Sorry about this. We just include everything that is outside the circle of B. It will be not B. So not A or not B. Not A or not B. What does or means? So we said that or means is the union, right? It's actually the union, or rather the intersection. You take everything in those things, right? In not A and in not B. So we're just gonna take everything that belongs there, right? Because it's or, it means union. So what belongs here? We have P, we have Y here. What belongs here? We have M. Here we have M. Sorry about that. Oops, it deleted everything. Sorry about that. Let me just quickly. It was yellow, not black. Let's just use it. Not B. It's this part. Okay. So there we just gonna put it was in A, it was M, right? And here it was Y, right? So for not A or not B, you go to not A and you take everything in not A, right? So in not A you have P plus Y, right? What is in not B here? Not B, you take everything outside there. So it is M plus Y again, right? So if you find that another outcome is repeating, you do not have to repeat it. Okay, so you just take, because you have already included Y there. So that will be the outcomes for not A or B, all divided by what? By the total number of sample space, which is M plus X plus what? Plus P plus Y. All right. So that's basically how you do it, right? So this is a much efficient way you can do it. Although there's another way, right? But just learn this way. You just draw 2 Venn diagrams and you go and actually deduce for each part, and you also include the what you have been given the or. What does or means? You take everything in those 2 events, not A and not B. Let's just quickly go and do number 4 so that you can also conceptualize this in a different situation. Okay, so for number 4, it is this one. They want you to get the probability of not in A and not B, right? It's very different, right? Okay, so they want probability of what? Not A and not what? Not B, right? So what you do is you're just gonna draw 2 Venn diagrams again, right? I won't draw the second one. I'll just use this one that we have here. This is A, this is B, this is M, X, P, Y. All right. So I'll just name this This is for not A, and I'll just name this one here. That is for what? Is for not B. Okay, so not A, not in A, we are excluding everything in A, right? So it's gonna be why am I using black? Sorry about that. Let me highlight using this. Not A is everything outside A, right? Then we go to not B, right? Not B is everything outside what? Outside B. Everything outside B. It's not B. Okay. So then, very, very important. What they need here is not the same as number 3. As number 3, they said or, right? And when they say or, we just took everything in not A and not B and we added them up without repeating, right? When they say and, is the intersection between not A and not B. What is something common between not A and not B? Right? So what is something common there that we have in not A and not B is Y. Can you see that Y is common in both those events? So it's Y, right? So we're just going to say the answer will be what? Y divided by the total number of sample space, which is M plus X plus P plus what? Plus Y. Okay, so be very careful. If they say and is the intersection between the two, between not A and not B, what is the intersection? What is something that is common? It's Y, right? So that's why we only use the Y as the outcome there, divided by the total number of what? Of sample space. Okay, let's quickly move to number 5 now. Number 5. So in number 5, they want you to determine probability of not A or B. Okay, very interesting. We want, if I can write this properly, it's probability of not A or B. Okay, so we're just gonna draw another Venn diagrams, right? If you have complementary events, for you to be able to solve this, you just need to draw up 2 Venn diagram and you just do it separately, integrate, and there you go. All right, so I'm just gonna draw. I don't know, we don't have space. Let me just put it here, even if it's gonna be quite small. So AB, so this is event AB MXPY, right? I'm just gonna name this not A, and I'm just gonna name this one on top B, right? Because we want for B. Okay, so we're just gonna go and shade. Not A, it's everything that is not in A, so it's all these things, right? Outside A, right? Great. Then B is everything that is found in what? In B, right? Everything in B, right? In that circle for B. Okay, so we go back and we check what does or means, right? When we say or, is the union. We take everything in not A and in what? In not and in B. Okay, so everything in not A and in B. Everything in not A, there is P plus what? Plus Y there. Can you see that is shaded P plus Y in not A? And we also take everything in B, but without repeating, right? There is X plus, we would take P, but we have already taken P there, right? So we don't have to repeat that. Okay, so we take all those things and we divide by the total number of sample space, M plus X plus P plus what? Plus Y. Okay, let's now move to number 6. Okay, number 6. I know it's a bit of a mess on this paper. Sorry for that, but hopefully you'll be able to conceptualize this. Okay, so in number 6, they want not A and B. It's different when it's and, right? And we did explain, and I'll just explain again that, right? So this number 6 is the same as what? As not A and what? And B. So we need to draw another Venn diagram for us to be able to do this, right? Let me just see where I can put it. I can just put it there. We have A, we have B, we have M, X, P, Y. Okay, so I'm just gonna name that one not A and I'm just gonna name this B again, right? So not A, it's everything that is found outside A. So there we go. And B is everything that is found in B, right? So the difference here is that this one, it says what? It says and. Can you see? Not A and, right? And B. So it means we must take the intersection, or rather something common in not A and something common that is common also in B, right? What is something that is common in not A and in B? So it's only what? It's P that is common between the two, and that is their intersection. So it's just gonna be P divided by the whole sample space, which is M, plus X plus P plus what? Plus Y. Okay, let's now look at how you can draw a Venn diagram, right? And also find probabilities from that Venn diagram. Okay, so this is an example, right? So they gave you that there are 220 boys in grade 11, right? 220 boys in grade 11 at Sunnyvale Boys High, right? So 160 of them play rugby, 110 play cricket, and 70 play both rugby and cricket. They say illustrate the following information using a Venn diagram and find the probabilities that a boy chosen at random will number A, play rugby or cricket, and all those kind of things. Okay, so you need to be able to know how to draw a Venn diagram. Very, very important, right? So this is a two events Venn diagram, right? We only have event for rugby and also another event for what? For cricket. So we're expecting something like this. Okay, so we'll have our rugby and we'll have our cricket, right? So when you want to draw a Venn diagram, always remember that you must start at the intersection first, right? That is very, very important. You must start, always remember that the intersection must go first. NB, highlight this, very, very important. It means that you start at the intersection. After the intersection, you go outside at this place where it's rugby only or cricket only. Then you lastly go on the outside, which is neither rugby or cricket. Okay, so that's how you draw your Venn diagram. So similarly, we're just gonna start at the intersection, right? So they've already given us the answer for intersection. They said 70 play rugby and what? Both rugby and cricket, meaning that at the intersection we have what? We have 70. Okay, so what if they don't give you the intersection? You just put X, right? You can use any variable to show that that is an unknown. Okay, so but in this case they give us 70 play both rugby and cricket, meaning that at the intersection you just put that 70. Okay, very, very important. Okay, they are saying 160 play rugby. This is very also an important statement, right? 160 play rugby. It means that in the circle for rugby we want the total to be what? 160. So don't make this mistake where you come and put 160 here, because if you put it there, you are saying rugby only is 160. So the idea here is that 160 can be playing rugby and some number there can also be playing cricket, right? Someone can be playing rugby and cricket, so they can be that intersection. Unless they told us that 160 play rugby only, we were just gonna put it here, right? But in this case they just say 160 play rugby. It means that the whole oval or circle for rugby is all equals to what? To 160, right? Meaning that we can now come and say 160, it's the whole thing. I can just let this to be X, right? Then I know that for rugby it's X plus 70. The whole circle will be equals to what? 160. Then I can now go and solve for that rugby only, right? So it's gonna be 160 minus 70. So it's gonna be what? It's gonna be 90. Okay, so we know that there we're just gonna put what? 90. Okay, very interesting. So when you add 90 plus 70, the whole thing for rugby must still give you what? must still give you 160 because 160 must be for rugby. Okay, so that's basically how you do that. Okay, let's now move. 110 play cricket, right? Very interesting. 110 play cricket, meaning that the whole circle for cricket will be equals to what? 110, meaning that if I just let this one to be y, I can say 70 plus y is equals to what? 110. Then you go and solve for y. It's going to be 110 minus 70. So 110 minus 70 is going to give you what? 40. Meaning that those who plays cricket only, there are how many of them? 40 of them. Okay, so we are not yet done. What do you have to do after you complete the whole thing? You must now go and add your numbers inside those events, right? Such that and you compare them with the total number of people that must be in those two events. Okay, so we're just gonna say 90 plus 70 plus 40 is equal and we get the sum of that, right? So it's 90 plus 70 plus 40. It's giving us what? 200, right? Only 200. But they told you that there are how many? 220. That is the total number of sample space. Our total number of sample space is what? 220. So meaning that there are others who do not play rugby or cricket. And how many of them? So we have 200 who plays rugby, cricket, and all those. So we have 200 of them. So but the total number of sample space is what? Is 220, meaning that these other 20 do not play rugby or what? Or cricket, because the total number of sample space should be 220. Or rather, you can just say 90 plus 70 plus 40. Then you know that there must be something outside. You can name it Z, plus Z is equals to what? 220. You go and solve for your Z, you'll still get that 20. Meaning that on the outside there, we have 20 of them. Okay, so that's how you sketch your Venn diagram. Very, very important. We say you must start first at the what? At the intersection. Then you go to the events. If it's rugby only, cricket only, then you go outside. And that's basically how you do this. Okay, let's now go and calculate these probabilities that they want from this Venn diagram. Okay, A, they said find the probability that the boy chosen at random, number A, plays rugby or cricket. So the one probability of rugby or what? Or cricket, right? Rugby or what? Or cricket. How are you going to find that? So we already discussed that the probability of rugby or cricket is the same as probability of rugby union cricket. So what do? You take all probabilities in your rugby and all probabilities in your cricket without repeating. Okay, so it's gonna be what? 90 plus 70 plus 40 divided by what? The whole total sample space, which is 200 and what? And 20. So this will be 200 divided by 220. Then you can just divide the two to finally get the answer. It's giving us 10 over 11, right? You can convert it into percentage or write it as decimal depending on what the question told you, right? So that will be the answer for that probability. Can you see that we were able to calculate this probability using our Venn diagram? So if you don't know how to draw a Venn diagram, it will be very impossible or rather difficult for you to get that answer. Okay, so let's now go to B. They want the probability that the boy chosen at random will play neither rugby nor cricket. Neither rugby nor cricket. It means outside the two events. And what's the answer there? It is 20. So the probability of neither rugby nor what? Nor cricket. Not rugby or not cricket. Is going to be what? 20 out of what? Out of 220. Okay, so it's gonna be 20 out of 220. This is the same as 1 over 11. Okay, let's go to C now. Okay, so on your C, they want you to get the probability that the boy chosen at random plays only one of the two sports. Only one of the two sports. The probability that the boy will be chosen will play only one. So we must go on only that particular sport, right? So on your only, you have 90 boys who plays only rugby, right? And you have another 40 boys who plays only what? Only cricket. So meaning this probability will take the ones for those only, right? So for rugby only, or what? Or cricket only. Okay, so this is the probability for rugby only, or what? Or cricket only. Okay, because they said only one of the two sports, right? So it will be what? Rugby only, we have what? We have 90, right? Plus cricket only, we have what? We have 40 of them. Then we divide by the total number of sample space. Okay, so it's gonna be 90 plus 40, and which is 130 divided by 220. It's gonna be 13 over what? Over 22 as our answer. Okay, let's not lastly go to number D. So this is quite challenging. They said determine the probability that a boy chosen at random does not play both sports, right? Does not play both sports. How can we represent this using probability? So this is the same as probability of um, rugby and cricket prime. Not rugby and cricket does not play both sports, right? In other words, we are excluding the intersection. We are saying do not play both sports, right? So it will be the rest of the probabilities, right? So this can be calculated by saying 1 minus probability of rugby and what? And cricket. Okay, so we are excluding the ones who plays both sports because they want the one that does not play both sports, right? So that's the formula for complementary rule. So it's gonna be 1 minus what is the probability of rugby and cricket? It's 70 out of what? Out of 220. Okay, so this will be the same as 15 out of 22. Okay, so that's actually how you can calculate that, or someone can calculate it differently. Let me write it on top there. Our number D, they want the probability that the boy chosen at random does not play both sports, right? In other words, you are including those who plays both sports, right? And take those one who does not play both sports. Okay, so those will be the same as what? We are excluding the intersection actually, because intersection they play both rugby and cricket, and we want those one who do not play both sports, right? So it's gonna be what? 90, right? So it's if I can highlight it for you, it's this part, and outside, because they don't play any sport at all, right? So it's gonna be what? It's gonna be the same as 90, 90 plus 40 plus 20 divided by what? By 220, because this is probability, right? So 90 plus 40 plus 20 is gonna give you 150 out of 220, which will give you the same as what? As 15 out of 22, as we calculated down there, right? When we just say use complementary rule to say, okay, probability that does not play both sport is same as probability of not R and not rugby and not cricket. Okay, so we are excluding both sport, which is we use just use this formula and we substitute it there. Or rather, you can just come here and exclude the intersection, which means that they play both sport, and you just add the things on the outside, and you finally get your what? Your answer. Okay, let's now move to another interesting exam kind of a question that you can really expect in your exam, and this is very interesting, right? Okay, let's take a look at this other interesting example. They said the probability that a grade 9 student chooses maths as a subject is 0.7, right? And chooses geography as a subject is what? Is 0.3. Then the probability that he takes neither of the two is 0.2. Find the probability that A, he takes both maths and geography, B, he takes only one of the two. Okay, so you're given two events here, right? So in order to solve this, you can just quickly draw your what? Your Venn diagram. It will make things easier for you to be able to deduce these probabilities that they need. Okay, so we're just gonna draw two Venn diagrams. So it's for maths, I'm just gonna write M, and geography G. Okay, so they have told you, and it's very, very important. We said when you draw a Venn diagram, you must always start at the intersection. Okay, so we're just gonna start at the intersection. Did they give us any information about learners who are taking maths and geography? There's no such information, right? So we're just gonna write X because we don't know it, right? Then we're just gonna solve for X in the future. Okay, so they are saying the probability that a grade 9 student chooses maths is 0.7, right? So meaning that we know the answer for the whole intersection here, right? It's what? It must be 0.7. So let's say, for instance, it's just gonna be, because we have X, it's gonna be 0.7 minus what? Minus X, so that we exclude the intersection. Then that one will be for math only. Okay, so because this 0.7 for math might be also including the ones who take geography, because they didn't say maths only. Okay, so they're just saying the whole circle for maths, and there's that intersection between maths and geography. So hence we are saying from 0.7 we are subtracting those ones who come from the other intersection for geography, so that we can have for math only. So it's going to be 0.7 minus X, right? Okay, so they told you that the one who chooses geography is 0.3, meaning that the whole circle for geography will be equal to 0.3, meaning that geography only will be 0.3 minus those ones who also take maths, minus X. Okay, so that's basically how you do that. And they also give us that the probability that it takes neither of the two, that is the one that lies outside the two events, is what? Is 0.2. So we're just gonna put 0.2 on the outside. Okay, so now before going and calculate these probabilities, we must first solve for X, right? We must first solve for what? For X in our Venn diagram. Okay, so how are we gonna solve for X? We know that the sum of all probabilities must be equated to what? To 1. Okay, the sum of all probabilities in a Venn diagram must all be equated to 1, or what is known as what? As 100%. Okay, when we add everything, all the outcomes, they must be equated to 1 or 100%, because the probability of an event is always between 0 and what? And 1, right? So obviously for the whole Venn diagram, it will be equated to 1, right? Or rather 100%. So we're just gonna say 0.7 minus X plus 0.3 minus X plus 0.2 on the outside must all be equated to what? To 1. And we can now go and solve for what? For X. Okay, so it's gonna be 0.7 plus 0.3 plus 0.2. This will give us what? 1,2. So it's gonna be 1,2 minus X is equals to 1. So if we take this one, we transpose it, it's gonna be 1 minus 1,2, right? 1 minus 1,2 is the same as what? As negative 0,2. So then our X will be equals to what? 0,2. Okay, very interesting. We can now go and sketch a new Venn diagram, right? So we are going to sketch a new Venn diagram for when we substitute X equals to 0,2, so that we can now go and be able to answer those two questions. Okay, we're just gonna replace where there is X, I'm just gonna put 0,2, right? That's what you do. And where there is X there, we put 0,2, so it will be 0,7 minus 0,2, then it's gonna be 0,5 for math only, right? So this is 0,5. Then this one will be 0,3 minus 0,2, it will be what? 0,1. Then we have now completely filled that Venn diagram. Okay, so this is basically how you do it. So we can now go and answer, what is the probability that it takes both maths and geography? Okay, both maths and geography, it's the intersection, right? Is there in the intersection. It's for both maths and geography. The probability is equals to what? is equals to 0,2, right? Someone can say, why are you not saying 0,2 divided by the whole sample space? Even if you take the whole sample space, 0,5 plus 0,2 plus 0,1 plus 0,2, you'll get it as 0,2 divided by 1, which is still what? 0,2. Is because we have just used those probabilities to draw a Venn diagram. Okay, so the answer there is 0,2. Let's go to B. What is the probability that it takes only one of the two? Only one of the two. Okay, let's now go and calculate that. So for only one of the two, it's either he takes what? It's either he takes math only, right? Or what? Or geography only. Okay, so only one of the two is when is taking math only or what? Or geography only. All right, so this probability will be equals to what? 0,5 plus what? Plus 0,1 divided by the whole sample space, which is 1, right? So divided by 1, it will still be that one. So the answer will be what? 0,6. And that's basically how you do that. All right. Okay, so here's your interactive activity, right? So I'd like you to pause the video and write down and drop your answers on the comment section, right? I know that for drawing a Venn diagram, you might not be able to post your picture, right? For your Venn diagram sketch, but just give me your answers for these probabilities. Just pause the video and try to answer this question, then I will respond from there. Okay, let's now look at the Venn diagram for 3 events, right? All along we've been focusing on a Venn diagram for 2 events, where you were only given 2 events. But as you know also from your grade 11, you have this Venn diagram that has what? 3 events, and this is quite interesting, right? So how do you go about sketching this Venn diagram? Okay, very important. Like we said with 2 events, we said you must start on the intersection, right? But for 2 events, you only have 1 intersection, right? You only had 1 intersection. But when there is 3 events, you have a lot of intersection, right? So where do you start now? So you start at the center, right? You start at the center, at the intersection for all the 3 events. Okay, so that is our step number 1. We start at all the 3 intersection. That's where you start, right? Then you're just gonna move to the other what? To the other intersection. This is step number 2, where you go and focus on all the 2 intersection, where 2 events are intersection, right? Step number 1, you start at the all intersection. That's where you start if you want to calculate or rather complete your Venn diagram, right? Then you will move in step number 2, you go to the other intersections, the 2 intersection, all the 2 intersections. Then you go and you focus on the what? On those events only, A only, C only, B only, right? You can start filling those, and that will be your what? Your step number 3. So that's basically how you sketch your Venn diagram. And you can lastly go on the outside, right? You can lastly go here on the outside, and then you complete your what? Your Venn diagram. Okay, just some key highlights to this one. You know that here at the center where it is highlighted, it is the intersection for both A and B and what? And the C, right? It can be represented like this, or they can use those intersection symbols. A and B and C is the intersection for all the 3 events, right? None. Then we have this none, so it means it's outside, right? So it's basically outside. If they are to highlight, they will highlight it on the outside. Okay, at least 1. This is very important, and that's where a lot of students get confused. At least 1, right? If they say at least 1, so the word at least means that thing or everything, right? If I say give me at least 2 rands, right, it means that I want 2 rands or more, or actually all of it, right? So that's basically what it means. So if we say at least 1, we mean that event A or all of them, right? Event B or what? Or all of them. So it's basically all of those things, right? So be very careful if someone tells you give me at least 1 rand. They might want all your money, right? Because they are saying give me 1 rand or actually everything. Okay, so that's what the meaning of that. So basically that's why here we have to shade everything. It means that we shade all the events. That's the meaning of at least one of them. So it's basically all of them in a way. Okay, let's now focus on how you can sketch a Venn diagram for 3 events. And this is your example. They said there are 79 grade 10 learners, right, at a school, right? All of these take some combination of math, geography, and history, right? The number who take geography is 41. Okay, those who take history is what is 36, right? Let me just put it somewhere here. Geography is equals to 31. History, oh no, it's 41, right? History is equals to what? 36. Math, we have how many of them? 30 of them. Okay, the number who take maths and history is 60, right? So we have math and history is equals to what? 16. The number who take geography and history is equals to what? 6. And there are 8 who take math only, right? So we have 8 who are taking math only. Let me say M only. And only 16 who take history only. So history only, we have how many of them? 16. So they say draw a Venn diagram to illustrate this information. So you can see that we have 3 events, right? We have math, we have geography, and we have what? We have history. Okay, so we're just gonna draw a Venn diagram for this. Very interesting. So I'm just gonna draw 3 events. Okay, so we have math, we have history, we also have geography. Okay, so remember we said when you sketch a Venn diagram you must start at the what? At the intersection of all the 3, right? So you start there in the middle, right? So how many learners, you ask yourself, how many learners take all math, history, and geography? You were not given, right? So you're just gonna put what? X. Okay, so after completing the center there on your 3 intersection, you now go to the 2 intersection. That's step number 2, right? You now go to the 2 other intersections. Okay, so we're just gonna check now. We were given the 2 intersection, maths and history is equals to what? 16. Be very careful with this, right? Maths and history is 16, meaning that the intersection of maths and history, let me just highlight this for you so that you cannot be confused. Maths and history, all this intersection here must be equals to what? 16, right? So don't make that mistake that a lot of students do to now come to say this 16 belongs here, right? It's incorrect. So if you put it there, you are saying maths and history only, but the question didn't say only, right? They just say maths and history, meaning that we can also be including learners for geography, right? So if you need maths and history only now, you are just given 16 as the answer for all this intersection there. It's 16, right? But now you need the maths and history only. So what you're gonna do, you're gonna subtract the X, the one that do everything, so that we can be left with maths and history only. So it's just gonna be 16 minus what? Minus X. Then you'll get your math and history only. So to prove that you have done something correct, when you add for maths and history there, okay, let me just use a highlighter. When you add for math and history there, you must still get your what? Your 16 as given in your question, to prove that what you just did there, it's correct to say 16 minus X. So to get maths and history only. Okay, we can now move. We can go to the other intersection. It is what? It is geography and history, right? Geography and history. Let me just highlight this, probably using a different color. Geography and history is this intersection here. Can you see? This is for geography and what? And history is equals to what? 6. So for us to get, we already have X, right? So for us to get geography and history only, so we're just gonna say what? We're just gonna say 6 minus X, so that we can be left with geography and history only. Okay, so we can now also go to the other intersection. When we're given the other intersection here, we don't know this intersection here, right? Let me just highlight this. We don't have this intersection here, right? We don't know for maths and geography, right? So because we don't know for maths and geography, we can just use, or rather put another alphabet there, right, to show that we actually do not know what is for math and geography, because we must first start with the intersection and then we go outside. Okay, so I'm just gonna put any alphabet. I can put Y here as the one for what, for math and geography only. Okay, all right, after doing this, we can now go to the maths only part, the history only part, and the geography only part, right? After you move from the intersection, you can go to those other sections that represent only those outcomes for those events. Okay, so we have 8 of them who are doing math only, right? So we're just gonna put 8 there because we were told that 8 it's maths only, right? History only, we have how many? 16 of them. Okay, so for history only, we put 16. Geography, were we told? No, we were not told, right? For geography only, right? So how can we do this? So for to get this one now, you can just now go and check what is the total for the whole circle for geography, right? So the total is what? Is 41, right? So because the total is 41, what you can now do is you can now go and subtract the rest of the things to get what? To get geography only. So you say 41 minus y minus x minus into 6 minus x. Okay, so that you can get for geography only. So it's gonna be 41 minus 6 minus y minus x plus x. So x and x will cancel. This will be 41. 41 minus 6 is gonna give us what? 35, right? So it's gonna be 35 minus what? Minus y. And this is for what? For geography only. So we're just gonna put 35 minus y. Okay. All right, so what's left now, it's for us to go and solve for our unknowns. Then we can now go outside and check what's remaining. Okay, so let's go and solve for our unknowns. So what you do to solve for your unknown, you're just gonna choose an event that has all similar variables, and you're just gonna equate with the total that you have been given in the information. Then you solve for that variable. So it's simple as that, right? So we can see that an event that is really preferable is what? Is history, because it all has its variable in terms of x, and we were given the total of history. It was what? It was 36, right? Meaning that you're just gonna go and add everything in the history event and equate it to 36, because that's its total, right? And go and solve for what? For x. So it's gonna be 16 plus 16 minus x plus 6 minus x is equals to what? 36. Okay, so it's equals to 36. Then you're just gonna solve for x minus x plus x. They will cancel out each other. Then we have 16 plus 16 plus 6, which will give us what? 38. So we have 38 minus x is equals to what? 36. So to solve for x, we're just gonna take 38 to the other side. So our minus x will be 36 minus 38. Then our minus x will be minus 2. X will be equals to what? X will be equals to 2, right? So after solving for x, we can now go everywhere where there is x, we substitute it, right? So we're just gonna go back and substitute x equals to 2. So at the center, our x is 2. I'm just gonna put 2 there. So 16 minus x, it will be 16 minus 2, which will be what? 14, right? 14. Then 6 minus x, it will be 6 minus 2, which is what? Which is 4. Is there any place where there is x? We have completed, right? So now we can now go again and go to the other events and solve for the unknowns, right? We have also y there. We have to solve for y, right? So on the geography one, can you see? So similarly, you do the same thing. You just go to geography 1 and you're just gonna solve for what? You're just gonna solve for y, right? Equating it with the total of what? Of geography there. Okay. Okay, so we're gonna say y plus 2 plus 4 plus 35 minus y is equals to what? 41, right? Is equals to 41. And then when you solve this, quite really interesting, a little bit challenging. Can you see that this is actually canceling out that, right? That one is canceling out that, meaning that it's just gonna equate 41 is equals to 41, meaning that we have to use a different approach now. Okay, meaning that we have to choose another Venn diagram, right? Another event, actually, not another Venn diagram, another event. We can go and choose for math, right? So you just play around with these things. So you're just gonna choose for math, and we're gonna equate with the total for maths, and that's quite easier for us to solve for y, right? So we're gonna say 8 plus 14 plus 2 plus y is equals to the total for maths. It's what? It's 30, because they told us 30 take maths, right? So you say 8 plus 14 plus 2 is gonna give us what? 24. So it's 24 plus y is equals to 30. So y will be 30 minus 24. Y is equals to what? Y is equals to 6, meaning that we can just go and replace everywhere where there is y by what? By 6. Okay, so it will be 35 minus y is 35 minus 6, which is what? Which is 29. Okay, so we have completely filled our Venn diagram on the intersection for all three, intersection for 2, and on the only part, right? So after doing that, we also need to add everything in our Venn diagram and see if it gives us the total that we were given here for the students. Okay, so we're just gonna say 8 plus 14 plus 2 plus 6 plus 16 plus 4 plus 29, right? We need to solve for a certain unknown outside, right? It is z, right? So we say plus z, it must all be equated to a total of what? Of 79, right? So we say 8 plus 14 plus 2 plus 6 plus 16 plus 4 plus 29 plus z, right? It must give us a total of and that one. So it's gonna be 79 plus z is equals to 79, right? Meaning that there is nothing outside, because z will be 79 minus 79, which is 0, meaning that we have nothing on the what? On the outside. So that is how you actually sketch a Venn diagram. Okay, I know that it has been quite a long one, but it is very quite easy to do this. Just follow the steps. Step number 1, you start at the center for all the 3 intersection, then you move, you go outside, right? Be very careful when you read the statement. If they're saying math is 30, they're not saying math only, right? They're saying the whole circle, the whole oval for math, it's equals to 30, right? If they say maths and geography is 16, they're not actually saying maths and geography only. They're saying the whole intersection for maths and geography is what? Is 16. So if you had already some value in that intersection, you have to subtract it from that whole total, right? Then you can now go and sum up and equate it and solve until you finally sketch your what? Your Venn diagram as required. Okay. All right, so here's your quick interactive session. I would like you to pause this video and start writing. Drop down your answers on the comment section, then I'll just respond from there to see if you are getting this correct or not. I know that for 5.1 it will be quite difficult for you to post your picture of your Venn diagram, but I'll just see whether you got correct answers by these answers from your 5.2 and also 5.3 for probabilities. Okay, just drop your answers on the comment section and let's see how it goes. Okay, so here's your another interactive session. Just pause the video and start writing. Drop your answers on the comment section. This is adapted from Department of Basic Education November past paper, grade 12, paper 1, and it was your question 11, right? Very interesting. You start seeing how they can ask you this question, and also this is also related to our first session, the previous one on probability, right? So they are saying for two events G and G, you are given the probability of G is 0.9, probability of H 0.3, and probability of intersection is 0.73. Are the two events dependent or independent? Right, so you have to use appropriate calculations and construct a reason for your answer. Right, what do you know about independent events? Recall from the previous session, if two events are independent, right, then we'll get the probability of A and B. The probability of their intersection must be equal to probability of A times probability of B. So basically you just need to calculate the probability of their intersection, and here fortunately you are given, then you need to multiply the two. If they're equal, you can conclude they're what? They're independent. If they're not equal, you can conclude they're actually what? Dependent. Okay. Okay, great stuff. This marks the end of our session. Thank you very much for joining this session. Thank you very much for your patience. And I know this has been quite a long lesson, but don't forget, we are aiming for what? For deep conceptualization of content knowledge. Okay, so otherwise, I hope you won't get any question about a Venn diagram confusing or rather challenging, right? And hopefully you'll just drop your answers for the interactive activity, and let's see how it goes from there. Okay, otherwise, thank you very much for watching. Thank you very much for joining us. Coming up next, we'll be focusing on contingency tables. I know that we didn't cover the part of tree diagram, but it's a very, very short session, right? I'm just gonna do a very short session on that on the future, but upcoming next we'll be focusing on contingency tables, and this is part of your probability, and let's see how it goes. Otherwise, that's all for me, and goodbye.